Hello, my name is Nicole Elizalde, and I'm going to be presenting my key activity. In this project, I will be analyzing and studying topics such as free fall, resistance, and the surface area of an object. In order to carry out this project in the best possible way, I will support myself with the following research question. How does the surface area of an object affect the time it takes to hit the ground? Also, I'm going to focus in different variables, both dependent and independent, for the results to be more accurate. What I think is going to happen is that as the surface area of the object becomes smaller, the time it will take to hit the ground will decrease due to air resistance. But first, I'm going to give you a little bit of background. First, free fall. We refer to free fall as the motion of an object where the only force that is acting upon an object is gravity. In this area, it is studied the relation that exists between force and momentum, which is based on the work of Isaac Newton. Free fall is considered to be a uniform accelerated rectilinear motion, where the acceleration is the gravity and it's always constant, is minus 9.8 meters per second squared. When it comes to the study of free fall, we will use a system of reference where the origin coordinates belong to the bottom of the y-axis and the upward direction will be positive. Let's pass to a resistance. A resistance occurs when the object's leading surface has some kind of collisions with air molecules. There are two important factors that have a direct effect upon the amount of air resistance, and these are the speed of the object and the cross-sectional area of the object. The variables that I used in this experiment were the surface area of the base, that was the independent variable, the time, that was the dependent variable, and the height, mass, gravity, initial velocity, and angle were the control variables. Let's pass to the methodology. The materials that I used were aluminum foil, a stopwatch, ruler, and a tape. In this experiment, I made 5 trials for me to have enough measurements to make a good analysis. All the trials were done from the same height and in the same conditions. For each trial, I changed the figure made with the aluminum foil. All the figures came from a square of 10 times 10 centimeters. I drew the figure and measured the time it takes to reach the ground. Then I wrote the data collected in a table where one column was for the dependent variable, that is the time, and the other for the independent variable that was the surface area of the base. Here you can see the results that I obtained from the trials. In the left part of the table, you can see the surface area, the results of the surface area that were measured in meters squared, and in the right side, it's the results of the time in seconds. I ordered the results from the one that had the greater area to the smaller one, and the time also, you can see that it starts decreasing the time. I have to mention also that the uncertainty for this surface area measurements is of plus minus zero point 0.1 millimeter, and the uncertainty for the time is of plus minus zero point 0.01 seconds. The results. For the experiment, as I mentioned previously, all the figures I made came from a square of aluminum foil of 10 times 10 centimeters. Both in the graph and in the table of measurements, we can see that as the surface area of the aluminum foil decreased, the time it took to the figures to reach the ground decreased as well. By observing the graph, we can notice that at the beginning, the line isn't as straight as at the end. This could be maybe due to the difference of time between the second and the third measurement. It wasn't as big as in the others. Also, there are many factors involved for the measurements to be like that. For example, the difference of areas between all the figures. Also, when the aluminum foil was falling in, sometimes it was like dancing a little bit in the air. Another factor is human error at the time of measuring the time. I think the last factor that I think it's like very notable is that the figures reached the floor quicker as they became smaller. And that's another very important factor. Here we can observe the trend line versus the original graph line. As we can observe in the graph above, the trend line I decided to use is the linear. It suits the original graph pretty much perfect. The only parts where we can see a difference is in the second measurement at 1.9 seconds. The trend line is a little bit above the original line. As it was mentioned previously, this could be principally because of the sizes and shapes that were used to do the experiment. Finally, the conclusions. Since the beginning, I considered that the line of the graph was not going to be exactly as the trend line, and that there were going to be huge differences between the measurements because I used totally different figures with different sizes. But I have to say that it turned out better than what I was expecting. With the experiment done, with the investigation and with the data collected, I can say that the research question was successfully answered. And as I stated at the beginning, as the surface area of the figures became smaller, they took less time to reach the ground due to air resistance. Finally, the data collected from the experiment adheres very well to the theoretical model. And here we can see a little table with limitations and improvements that I have to make. And the limitations that I had was that the aluminum foil lands a lot, as I said previously, in the air in some trials. And the improvement that I should make to fix that is to make more trials for me to get a better time average of each trial. The second limitation that I had is that I had problems stopping the stopwatch and the time the figures hit the floor. And the improvement that I could make is ask someone to measure also the time so I can have more data to get to a final result. Finally, here's the evidence that of me making the experiment and the references. Thank you.